Assalamu alaikum, dear students. Our today's topic is derivatives of functions in parametric forms. In this lecture, uh, we'll find the derivatives of functions in parametric forms. The first thing is what is meant by parametric form, and then how we can find their derivatives. Okay. Sometimes the relations between two variables is neither explicit nor implicit, but the relation is established by a third variable. Whenever we have a relation between two variables, that means y and x dependent and independent variable, when the relation is neither in explicit form nor in implicit form, and at that very time the relation is defined, is established, is expressed by some third variable. Such forms are called parametric forms. Like till now, firstly we have the functions, explicit functions, while y can be easily expressed in terms of x. Y can be easily written in terms of x. And then after that we have implicit functions where y and x it is not easy to separate x and y. Okay, but now when we have relations when x and y are neither in implicit and explicit form, but x and y is related by some third variable, at that very time uh, we call the relation is in parametric form, and that very third variable is called the parameter. Like we have a relation like y is equal to sine of t, x equal to cos of t. Y and x is not directly linked, but both the x and y are linked by some third variable, that is t, because we can x we can link them, or we can express y in terms of x by using t. Such forms are called parametric forms, and that way third variable, like in this very example which I say, just t is called the parameter. Now the question is how we find the derivatives of such functions. To find the derivatives of such functions, we use simply chain rule. And when we are seeing about the parametric equations, that means x and y are separately expressed in terms of some third variable, what we have to do, we simply differentiate both x and y with respect to that very third variable, and then after that we use simply chain rule to find the derivative. To find dy by dx, to find the value of dy by dx, we firstly differentiate both the equations with respect to that very third variable, and after that using chain rule we can find dy by dx. Now we are going to solve some questions of our text, that is of our exercise 5.6, to solve some of its questions. Okay, we have to simply to use chain rule. The very first question of our exercise is, if x and y are connected parametrically by the equations without eliminating the parameter, find dy by dx. X and y are connected by parametrically equations, that means by parameter t. Here we have to find dy by dx. It is given x is equal to 2at square and y is equal to 8 raised to power 4. Now to find dy by dx, we will differentiate both these equations with respect to t, so that we can get dx by dt and dy by dt. Then use chain rule, that is dy by dx equal to dy by dt into dt by dx or divided by dx by dt. Okay, the given equations are x is equal to 2at square and y is equal to at raised to the power 4. Then differentiate with respect to t, we get dx by dt, that is equal to d by dt of 2at square, which is equal to a constant t square derivative, that is 2t, which is equal to 4at. We get dx by dt equal to 4at. Now differentiate with respect to t, differentiate y with respect to t, we get dy by dt is equal to d by dt of at raised to power 4, which is equal to a d by dt of t raised to power 4, which is equal to 4at cube. Now we have dx by dt which is equal to 4at and dy by dt which is equal to 4at cube. Therefore dy by dx which is equal to dy by dt divided by dx by dt, or which is equal to 4at cube divided by 4at, which is equal to t square. T square is our dy by dx. In such way we find dy by dx, or we can say we find the derivative of a parametric, we find a derivative of a function which was expressed in parametric form, in the same way we can find we can solve the rest of the questions, or whatsoever the question is asked to you people, you can simply solve that. The steps are: firstly we differentiate both the equations with respect to the given parameter, then using chain rule we will find dy by dx. Like our next question number 3 of your exercise is, you have to find dy by dx where x and y are expressed parametrically. X is given by sine of t and y is given by cos of 2t. Our given equations are x equal to sine t and y equal to cos 2t. Differentiate both these equations with respect to the parameter, that is t. We get dx by dt and dy by dt. When we differentiate x with respect to t, we get dx by dt, which is equal to cos of t. And when we differentiate y with respect to t, we get dy by dt, which is equal to minus twice sine of 2t. Okay, that means that implies dy by dx equal to dy by dt divided by dx by dt, which is equal to, our dy by dt is minus twice sine 2t divided by dx by dt is cos of t, which is equal to minus twice sine 2t, that is 2 sine t cos t divided by cos of t. Cos t cancel, we get minus 4 sine t. Minus 4 sine t is our dy by dx. In this way we find dy by dx. Okay, every time when the relation between x and y is given parametrically, we have to differentiate both those equations with respect to the parameter, and then using chain rule we will find dy by dx. One more question of your textbook, that is question number 5. We have again find dy by dx. X and y are expressed parametrically. X is given by cos of theta minus cos of 2 theta, and y is given by sine of theta minus sine of 2 theta. The parameter here is theta. Okay, the given equations are x equal to cos theta minus cos 2 theta and y equal to sin theta minus sin 2 theta. The way first step to find dy by dx is that we will differentiate x and y, both x and y, with respect to theta. When we differentiate x with respect to theta, we get dx by d theta, and when we differentiate y with respect to theta, we get dy by d theta. Okay, when we differentiate now x by theta with respect to theta, we get dx by d theta, which is equal to d by d theta of cos of theta minus cos of 2 theta, which is equal to d by d theta of cos theta minus d by d theta of cos 2 theta, which is equal to different derivative of cos theta is minus sin theta, derivative of cos 2 theta is minus 2 sin 2 theta. Okay, that means dx by d theta is minus sine theta minus twice sine 2 theta, which is equal to twice sine 2 theta minus sine theta. Okay, now differentiate y with respect to theta, we get dy by d theta, which is equal to d by d theta of sine theta minus sine 2 theta, which is equal to cos of theta minus twice cos 2 theta. Okay, that means dy by dx is equal to dy by d theta, that is cos theta minus twice cos 2 theta, divided by dx by d theta, that is twice sine 2 theta minus sine theta. Okay, this is our dy by dx. Okay, one more question. The 10th question of your exercise of your textbook is x is given by a cos theta plus theta sin theta, and y is given by a sin theta minus theta cos theta. We have to find dy by dx. X and y are expressed by parametric equations. Here the parameter is theta. We have to find dy by dx. Again, we repeat the steps which we do in the last three questions. Firstly, differentiate both x and y with respect to the parameter, that is theta here. Then use chain rule to find dy by dx. The equations given here are x is equal to a cos theta plus theta sin theta. Firstly, we differentiate this very equation with respect to theta. We get dx by d theta, which is equal to a minus sin theta plus theta sin theta. प्रोडक्ट रूल अप्लाई होगा, ठीक. Here we use a product rule, that means theta as it is sin theta's derivative is minus cos theta plus sin theta as it is theta's derivative is 1. Okay, which is equal to a minus sin theta plus theta minus theta cos theta plus sin theta, which is equal to a theta cos theta, a theta cos theta. Again, now differentiate y with respect to theta, we get dy by theta, which is equal to a theta sin theta. Therefore dy by dx is equal to a theta sin theta by a theta cos theta, which is equal to tan of theta. In this way we find dy by dx. The rest of questions of your textbook are solved in the same way. Firstly, and differentiate separately the parametric equations with respect to the parameter, and then apply chain rule to find dy by dx. I hope you people can solve the rest of questions. Uh, if there will be any problem anyway, you can contact me. Okay, the rest of questions I hope you will try by yourself. Okay, and inshallah in the next lecture we will start the next topic, that is second order derivatives or derivatives of higher orders. Okay, thank you, have a nice day.